Good. Let's read this question. The paper company produce rules with a standard width of 20 feet each. Special customer orders with different width are produced by selecting the standard rules. Typical orders are summarized in the following. Customer 1 wants most of his feet to be 5 feet. He need 150 of the rules. 2, 7, 200, 3, 9, 300. In practice, an order is filled by setting the knives to the desired width. Find the minimum number of standard rules to select according to the given data. Formulate the problem as L.P.P so as to minimize the total wastage. Now, this is the question in case you want to snap it or screenshot it before I remove it. Okay. In this case, I hope it is well. Yes, so you can take a picture of the question before I remove it. Okay. That's good. Let's see how we can solve it. Now, the item the company produces, each item is in 20 feet. As a data scientist, as a person who wants to minimize cost, the customers has given their orders. And this is the shape, the sizes they want. Any size aside from this is a wastage. No one need them. I hope it is well understood. So the sizes you are going to cut it should come in 5, it should come in 7, it should come in 9. Example, you shouldn't cut size 10. No one needs size 10. You shouldn't cut size 8. No one needs size 8. They've given you their desired width. Good. So you are going to check how many times you can cut these shapes. When you take 20 feet, when you take one item 20 feet, can I get 5 from it? Can I get 7 from it? Can I get 9 from it? If I can get 5 from it, how many 5 can I get? If I can get 7, how many can I get? You are going to check. So the ones with the minimum wastage, that is what you are going to use. Now, let our formula be 5A, 7B, 9C. So we have 5, 7, and 9. I'm doing it in a blind spot, so pardon me if I don't write it very well because I have my camera in between my eyes and my sheet so that you can see the paper very well. Good. Now you ask yourself, do you want this shape 5, 7, 9? You first ask yourself. Each item 2 is 20 feet. The items comes in 20 feet. Good. Can I cut 5 from 20 feet? Yes, you can cut 5 from 20 feet. How many 5 can you get in 20 feet? I can get 4. So you can first cut one of your items into 5, 5, 5, 5. 4 times. Then you produce your 20 feet. Good. When you cut it that way, that means that you were not able to cut any shape with 7 feet or any shape with 9 feet. I hope you understand. Good. Is there a wastage? There is no wastage because 4 or 5 will give you 20. Okay, that is it. Another possible combination you can do is, okay, I can cut 5. You ask yourself, can I cut 5 3 times? Yes, you can cut 5 3 times. That is 5. Another 5 will give you 10. Another 5 will give you 15. But it will be left with 5. That means that the 5 will still be 4. So it will come back to this. So no need to cut the 5 into 3. I hope you understand. It will still come back to this one. Okay, you ask yourself, can I cut the 5 into 2? Let's check. I will cut 2 of the 5 feet. 1 of the 7 feet. Okay. If you cut 2 of the 5 feet, you get 10. Now, the 10 is 20 feet. You have cut 10 out of it. How many is left? You are left with 10 feet. 10 feet, you either decide to cut 7 from it or cut 9 from it. Any other shape is not needed. So we cut one of the 7 from it. So now we have 10 plus 7. That will give us 17. We are left with 3 feet. 3 feet cannot produce 9 feet. And no customer need the 3 feet. So 3 feet is a wastage. Did we get 9 from this combination? No. So we did not get any 9. When we cut it this way, we will not get any 9 from it. Another combination we can do, we can cut 5 feet twice and decide to cut one of the 9 feet from it. What about 7 feet? Now, twice of the 5 feet is 10. One of the 9 feet is 9. 9 plus 10 will give you 19. It is left with only 1. Does any customer need 1? No customer wants 1. So 1 is a wastage. Did we get 7 feet? No, we only got 5 feet and we got 9 feet. But we did not get 7 feet. So 7 is 0. You've seen how we do the pattern. Good. Another possible combination is that, okay, we can cut one of the 7 feet. Cut one of the 9 feet. 7 plus 9, because one of the 9 feet plus one of the 7 feet. So 7 plus 9 will give us what? It will give us 16. It is left with 4. 4 cannot produce 5 feet. If you use it, no customer also need 4 feet. So 4 feet is a wastage. Okay, another possible combination we can do is that we can decide that we will cut 7 feet twice. So we have 7, 7, 14. 14, it will be left with 6. 6 is a wastage, but remember we can get 5 feet from 6. Because if you have 6 feet, why don't we cut 5 feet from it? So we can get one of the 5 feet from the 6 remaining. Then it will be left with 1. No one need 1. No customer need 1. So we got 1 of the 5 feet and 2 of the 7 feet. Did we get any of the 9 feet? No. So 9 feet is 0. Another possible combination. Can we cut 9 feet twice? Yes. We can get 9 feet twice. 9 and 9 will give us 18. Remaining with 2. 2 cannot produce 7. 2 cannot produce 5. And no one need the 2. So 2 is a wastage. That means we know if we cut it this way, we cannot produce 7. If we cut it this way, we cannot produce 5. So you see the pattern that I'm using. You've seen it. You can arrange it anyhow you want. At the end of the day, we will all arrive at the same answer. Okay, so you can arrange it. So you will cut it in such a way that, number one, it will satisfy the customer's requirements. The customers need 5, 7, 9. Any other shape you cut is a wastage. Good. But it doesn't mean that necessarily you will get all what they want, because some want different shapes, some want different size. So it doesn't mean necessarily you can get all what they want. But what you can do is that after checking the possible combinations, you will check. This has a wastage of 0. This has a wastage of 3. This has a wastage of 1. This has a wastage of 4. You will sit down to think, why would I choose a pattern that I will get 4 wastage? Why don't I choose a pattern that there will be no wastage? You get it? You are trying your possible best to minimize wastage. Because if you cut it this way, all this will be waste and you have to throw them away. But if you cut it this way, you will get no waste. So assuming there was no 0, you will prefer the one with the less wastage. There can be further number of combinations that we can do. Let me try this. Let me try if I can get. It's not possible, but okay. Let me stick to this. Let me stick to that. I think there are further combination. In order for the video not to be long, we will stick to this. So in the part 2, I will give a further example, then we'll check the number of combinations. When you are done with this, you check all the patterns. So one of the patterns is 400. One of the pattern is 21020. But you check the ones with the minimum wastage, very minimum wastage, 400. We have 201. 201. We have 120. 120. We have 002. 002. We have 210. 210. And the last one, 001. So I've written all of them, but I've written it in ascending order. The ones with the mid. So if you are to go by, you first go by this, then you second go by this. So even if you are to choose 3 of them, you know which one are the best to choose. If you are to choose 4 of them, you know which one are the best to choose. You don't just blindly choose anything. So you arrange them in such a way that this has the minimum wastage. So you will always prefer this one. If there is a need to go to the second stage, then we will need this one in that order. If there is a need to go to the third stage, we will choose this one. But for example, you don't choose 001 as your first method of cutting because that one will provide more wastage. So if you get the number of items or the number of rows which can help you solve your problem, then you use that one. That's why I've arranged it in this order. Good. So in the part 2 of the video, you will check another pattern. You see how we draw the pattern. Then we will complete the question. So this is how you cut the patterns